Alright, time for another draftphysics.com. Debatephysics.com also. But nobody's bringing any counter arguments to the actual arguments being made in these videos. Yes, levers and any pressurized vessel proves 1/2 mv squared to be absolute nonsense. Can't possibly have anything to do with the real physical universe. Really can't, because it just is eliminated by so many experiments. But anyway, now we're on photons. Okay, and one of the popular science presenters, I guess that's what they're called, yeah, misinformation purveyors, whatever, really bad teachers, you could say, lots of things you could say. So this is a pathetically amateur effort. I mean, the mistakes are trivial. That is, they're so simple and obvious, and the deductions based on mistakes, misimpressions, fakery. That's all it comes down to. She's fooled, and now she's going to fool the audience. And that just makes a lot of fools. And I'll try to be polite about it. Won't say what I want to. Won't say it how I want to. I'll just try to keep it to the facts. And, but they don't do that. They don't play by those rules. Take lots of cheap shots against Isaac Newton and such. Troll the dead. It's very tacky, really. But anyway, alright, so this is supposed to be an advancement in our understanding of the double slit. This video was sponsored by, that means Google paid for it. So Google paid for this in some Australian thing. What the hell is it called? Let's see. The wonderful people at Screen Australia. So I'll have to find out what the fuck that is. But they paid for this, so there's no commercials at least. But it's horrible science. It's really bad physics. It's really bad logic. It's so amateur. I mean, it really just shows how dangerous a little information is. You have a laser beam and you can do stuff with it. And it's like she doesn't understand how this works at all. She doesn't understand anything about the subject. I just pointed at things and draw conclusions. See, I'm being judgmental. There's no way not to be. It's just such bad science. And this isn't the kind of mistakes Newton made. Okay, Newton didn't make these kind of mistakes. He didn't boldly say, everybody else is wrong and I'm right, and all that kind of crap.
How beautiful is this?
Okay, well, you can't hear that. It's all beautiful. So she's saying it's so beautiful. So this is all part of physics. So this is called looking glass universe. And I don't know what this symbol is, little la la la, and so I could, obviously this is a terrible way to introduce a physics subject, isn't it beautiful?
It's an experiment in quantum mechanics called.
Okay, I can't hear it now, so we have to go a little louder. Sorry, gotta get, it's hard to get this exactly right, volume-wise.
The double slit experiment, but I really didn't expect to see this when I did it myself. And
seeing this, now what she's seeing, let's just understand that all you're seeing when you put smoke in front of a laser beam is little locations where the light hits the target being the little molecule of water or dust. So all you've done is move the target, the end place, somewhere else. You've essentially just created a little piece of paper or card or wall, and you've moved it to all kinds of different locations, and you're saying, where's the pattern there? With my tiny little indicator. And that's all you're doing. So it doesn't show you anything about how the photon got to the target. The target is doing the same thing. No matter how far I move the target from the two slit or the single slit pattern, I get the same pattern. It doesn't matter whether the target's this far apart or 10 miles away. It will shoot the same lines, okay, because it's going to make the same pattern. It's just going to make it bigger. but it's going to go exactly the same vectors because the math requires it to be the same vectors. So it doesn't change anything. Now the flat surface does change something, and that does it does distort the image slightly, spread it out, create an illusion. It cheats it a little. The light hits spaces it wouldn't have hit if you used an arc. But all you're really thinking of is the target as an arc you're putting in front of the light, and you're just making the arc bigger and bigger, and the vectors are going to be exactly the same. So this would be exactly what you'd expect. If you just move the target closer, the pattern stays the same pattern, and it just gets smaller and smaller and smaller. But it's exactly the same pattern. So, I mean, this is a trivial illusion, okay? This isn't even close to a magic trick, okay? You're not seeing the path of photons that reach the target. You're seeing photons that don't reach the target, that have been created in a different location and now have been reflected to your eye. They're way off the path. They're not going to hit the target. They're not going to make a band of light. The photon you see here isn't making the beam you see here. No, you used the photon up here. You made it there. The two vectors, if it was a slit experiment, have already combined here. Now the trick is, this is actually a double slit, which he doesn't do in the actual video. So, instead of saying, gee, isn't this quite curious, this pattern, this double slit pattern, how do I make that with two waves? That certainly won't work. So instead of doing what she should be doing, which is explaining the real double slit experiment, she's doing this trivial, look at the pretty pictures.
This changed my mind on an important question in physics.
Alright, so it says she changed her mind. It didn't change anything. She had some personal, perspective where she thought the photon was actually a corpuscle, and that it somehow turned into a wave and then landed at a corpuscle. So it's her own individual theory of light.
What is light?
But before all that, here's a simple experiment that you can do. All you'll need is a laser pointer and a strand of hair.
Yeah, just do it trivially. Do it in these amateur ways and pretend you're doing good physics. No, that's not a good idea.
So if I just take this laser and I shine it at this whiteboard here, you can see that you just get a dot. But
you don't just get a dot, though. That's, the truth of it. You really don't. Sometimes you get a square. Sometimes you get all kinds of funny shapes, actually. And clearly it gets much bigger the further you shine it. So the further away you make the dot gets bigger and bigger and bigger.
What do you reckon will happen if I put this hair in the way?
You might expect...
Well, you might. If you don't know what a hair looks like, you'd say, oh shit, I'm going to get some funky stuff, actually, because hairs have all kinds of weird irregularities in their surface. Just kind of a fact.
the dot to get split into two dots, or for there to be a dark line through the dot, or nothing at all to happen since...
So, look, we all know already, right? So I don't know who's it made for the video. You're saying what, this is like trivial stuff. We know Newton did the experiment, okay? So Newton did this experiment in the 1600s. The 1600s, without lasers, okay? And he did the experiment. We all know what it happens.
The hair's so small. But let me show you what actually happens in the dark.
So, again, this is supposed to be, I guess, for people who know nothing about physics whatsoever. So that's sort of critical, right? Because, that's even more of a cheat, because you're taking advantage of people who haven't seen magicians before. And you're going to do your little magic trick.
Because it looks really impressive.
Surprising, right? And it's nothing to do with the hair itself.
Well, of course it has everything to do with the hair itself. The hair is exactly why there's a pattern, because, you're running the light across two surfaces. And so this is where, there's no point in me doing this without the context of saying, well, let's talk about what actually we know happens. So instead of talking about your little fantasies, let's talk about what really we know to be a fact. All right. So the part she'll totally ignore in this video, okay, is one of the key components of the whole thing, is the understanding that the true double slit pattern is two patterns, okay? It's two patterns for fun kind of thing. All right, well, you can almost see that. All right, okay, so you have this, what's called an envelope pattern, okay, the single slit envelope pattern. That is, it has a double maxima here in the center. This is twice as big as these things on the sides, and these continue, okay, with what would be 3 nodes, except they get less and less visible as you go further out because there's less photons that end up going further out, and we don't know how far out they actually go. This is something physics hasn't really explored. But anyway, you can clearly see there's this clear place where there's no light, okay, a clear component. Now their theory is, okay, that the double slit pattern is creating a wave here and a wave here, when they can know mathematically that doesn't work. This as a source, okay, this is the center of the wave, right? If I use this distance, I won't predict either these locations or this envelope. Neither one of them will be true to that. Okay, so the waves can't be in those locations. This is the Young drawing. So let's understand that this is the famous Young double slit experiment. Young's drawing did not get correct mathematical answers. It doesn't match the actual pattern. So it isn't the truth. And you can know it on the face that it can't be the truth because, well, there has to be 2 waves in the single slit. And where am I going to put those waves? I mean, there has to be 2 waves here, right? And the distance that works, the distance that gets a pretty close answer, the distance that would predict exactly where those bands are, in her hair example, is the distance between the surfaces. That's the distance, the math that works. And the math is really just saying, well, here's a vector and here's a vector. Is this line, okay, a whole wavelength, close to a whole wavelength, or as far away as you can get from a whole wavelength of difference? Is it cutting the wavelength in half, the distance, or is it on the wavelength? That is, the new start happens exactly on phase with the old one. So you have 2 different things and you're going to start them at different places. And so it's like a really short round track, you could argue, right? And one guy goes around the track and then the next guy starts the second time around and the next guy starts the third time around, you could say. It's like staggering on actually round racetracks. They actually stagger the racers for the outside to the inside and to keep them in phase, so to speak. So all you're doing is measuring a vector, a straight line. So the wave is understood to be, I mean, this isn't a reach, right? You could sort of understand that a wave is sort of a focus with a bunch of radians, okay, spokes, that you could understand that's what the wave is made of. That's the geometry, that's what the math is recognizing. The math isn't seeing this arc. The math is seeing these spokes. That's how the math understands the wave. So just understand that as a fact, okay, that these are the vectors. These are the lines. These lines will decide. The vectors from the source, okay, of the wave, the center, the focus of the wave. All right, so obviously the waves have to be here and here, right on the surfaces. That's where the source has to be in the single slit to have the vectors match and to get the right answer. So to get the right answer, you have to draw the waves here, focused on the surfaces. All right. Now, obviously, I could do that with particles and just say the particles scatter off the surface. So, yes, my argument is the surface is covered in electrons because we know atomic theory. No protons, just electrons. And the photons will be traveling through that sea of electrons. And that electrons do, in fact, scatter photons. That is, the photon can go in any direction based on what the electron is doing. So whatever the electron it hits is doing, it will combine the photon's momentum, so to speak, and you'll get a new momentum for the photon, a new direction. All right. Simple enough, really, frankly. But it won't be the same photon. The electron is actually moves, which produces a new photon. But whatever, we're not going to get into all that. So the argument again is whether there's a particle theory, corpuscle theory of light, or a wave theory. Now the corpuscle theory in Newton's day, now Newton would say, okay, is it a particle? Now he didn't know 500 nanometer frequency. He didn't know any of that stuff. But he must have had some idea of the idea that you change the distance between the particles and you can change what the light looks like. So there's two ways to do that, right? You can make the particles bigger, okay, and bigger, and say, okay, it's a bigger particle. So you'd say like a low frequency radio wave is a mile long particle. Well, I think Newton would say, no, what a simpler answer would be is that you start with a little particle, you wait a period of time, the wavelength of time, and then you just send another particle. And there's your frequency. Your wavelength is the distance between corpuscles. Not that there's one corpuscle. So, again, particle theory has to be understood that, all right, Feynman and a lot of other people want to say that the theory says this. When, no, that's not what the theory says. The theory doesn't say you have a mile-long particle. The theory says you have sent a signal of little tiny discrete quanta, and that you have a frequency between their arrival, and that's a photon. A photon is made of particles. A photon is a compound object. It's an event. It's not a singularity. It's not a thing, okay, not made of parts. Photons are made of parts that are a particle. All right, do I really need to say more? I mean, I've already proven or demonstrated that if you want to understand this complex pattern, all you have to understand is when you bring two single slits together, what you've created is 4 point sources, 4 waves. Like the single slit is 2 waves. Well, the double slit is 4 waves, all on the surface. Four sources, point sources. And what you basically have now are 2 point sources that are very far apart. Okay, that means lots of possibility of making a wavelength of difference. The further apart I make 2 point sources, the more places I can have a wavelength of difference. It's just a fact. So the little bands, the little bars, are being made by the 2 distant point sources, and the envelope pattern, the much bigger pattern with fewer nodes, that's being made by the small distances. The small distance between point sources means very few points. And where all 4 sources are in phase, that's where you get a bright. And only 2 sources will be in phase here. Only the 2 outside ones are in phase at this location. The 2 short distances aren't producing any light. They aren't sending pieces in phase. They're sending pieces, but they're not in phase. So there's no photon. That's the accurate explanation. That's the one that can be factually defended as a theory. All right. So back to the horrible, bad, terrible video.
You can do the exact same experiment with anything thin.
So again, the single impediment experiment is just the single slit experiment. It's 2 surfaces. These experiments are all just about surfaces. The surfaces are overtly in their own math. Their own math measures the distance between the surfaces. That's what's put into the math. That's the source of the wave. The surface. The wave is on the surface. So let's just understand, they've already proven this. They're already conceding part of the argument. Their mathematics overtly says one thing. They draw it like Young's experiment. They draw it differently. But their math tells you the truth of what works. And what works is understanding the surfaces are the source. All the fringe light, all the light going across, all the light here and over here, all of those photons, the things that are making those photons, the bits that are making those photons, had to travel next to a surface. Their origin is a surface. None of them went straight through. None of their parts have anything to do with any of the photons that are hitting that very bright center. They're just the tiny number, the small number, the 10% of the photons that went next to the surface and encountered an electron.
This is a variation on the double slit experiment, which is an experiment that's so important you learn about it
right, and you just take two pretty poor pictures of it. Okay, so you haven't improved the photograph of the experiment. You haven't shown us its detail with any refinement. So far, so bad. You've just gone backward instead of forward in terms of showing us an experimental piece of evidence. I mean, you're doing the science in the wrong order. You're not supposed to go backwards. You're supposed to add value. You're not supposed to essentially subtract value.
Pretty much day one of any Quantum 101 class.
Right, and so you've already done some trivial little kid kind of videos preaching the dogma. Okay, and that's all it is a dogma. The Young double slit experiment that you don't show, that you don't accurately diagram. Again, Thomas Young wasn't viewing the true double slit experiment because his machinery and mechanism was so crude, and the tiny slit width eliminated the double slit pattern. It just ended up creating 2 point sources that were so close to each other that you didn't see them. So it was just really a 2-source experiment.
The way to do the experiment is to shine a light on 2 very narrow slits. Then the light that goes through...
So why very narrow? Again, they don't have to be very narrow. They really don't. You'll get lots of pattern having, 0.5 millimeter wide slits. Just a fact. All right? And what you'll get is the complex pattern. The pattern with more than one element in it.
Goes through the
one that can't be explained by a 2-wave theory. The one that can't be explained by the Copenhagen model.
Left or to the right.
This variation is pretty much the same. The light goes through one way or the other. But
so this one way or the other, again, the only light that ends up part of the fringe pattern is light that comes from the surfaces. That's what the math dictates. The math is already confirmed. That's when you'll get a right prediction of the pattern, is when you recognize that the surfaces are the source.
Besides being easier to do this way, the other advantage is...
So again, just really horrible pictures. You should just use somebody else's imagery. You can't see anything here. So she does the double slit, but you obviously can't see anything here. It's just so bad. Obviously, there's breaks in all of these locations that you're not being able to see. It's, it's the drawing I did. That's the real pattern.
Is the pattern you get. You can see that they both have the same sort of flavor, but...
Okay, so, it's just sort of, again, this is not science, okay? This isn't about a flavor. This isn't about it looks like. It's about... is there something distinctly different about these 2 patterns? And yes, there is something distinctly different about the 2 patterns. The 4-source pattern is quite distinctively different than the 2-source pattern.
They're different. For example, the dashes of light for the hair version are all evenly spaced and get...
So again, they're not evenly spaced. Even recognizing the actual truth is that they get bigger and bigger and bigger as you go around the arc. So it's just, again, not true, okay? Because it is basically on an arc. The distance is always the same. If you're going the same length from a single point, you can't go way over here to the flat surface. You have to go a circle, a radius. If you keep the distance the same distance, then it's a radius. All right? And on that radius, the points on this side are going to be much bigger than the points on this side, because a little bit of movement here, all right, very different than a little bit of movement going tangentially. All right, so on the tangent, you need a lot more angle to create a node, and on the, going straight, you just need a little tiny bit of difference to create two lines. Okay, you're making two lines. You're making a triangle essentially, and you can understand that this triangle has a much bigger area than this triangle.
Lighter as we go. But the dots of the double slit are much more patchy.
So patchy and all this, no, they're not. If you do it well, there's no patchiness. It comes out quite clear. There's really good images on the internet of double slit patterns. So again, there's nothing patchy about it.
That's because of something called single slit interference, which...
So she says single slit interference. So the double slit has single slit interference, whatever that is. So let's understand that's not a thing, okay? It's not a real thing. She just might as well say magical gremlin interference. This doesn't mean anything. This is mush, okay? So she's mushed her way out of dealing with the real double slit pattern, explaining the real pattern that has the two patterns superimposed on it with two sources. Two sources can't explain these two patterns. And neither one is going to be explained, okay, if you make the slits bigger than the wavelength of light. You can't mathematically deal with that pattern without creating four sources. The only math that'll get the right answer is math that recognizes the four sources.
Is basically a distraction in this scenario. So yeah, I kind of prefer the hair version.
Alright, so she prefers the single slit and she titles the video double slit. Do you get the lie? Come on, I mean, it's just, let's just play games with words, play games with concepts, so we can propagandize for a bad physical concept, a concept that's wrong. Okay, photons are not waving an ether, they're not waving fields, they're not going this way like water waves. They're not going, water waves are going up and down, yet the water waves going this way. They're not doing any of that crap. But that's the theory they wish to shove down the mind of man.
Plus, check this out. I'm using this smoke in a can stuff to see the actual beam, but look really closely at the beam, and you can actually see where the hair splits the light into two. How crazy.
Yeah, crazy. You can see the shadow, okay, of the hair. Yes, the hair stops some of the light from going through, and you're not going to see as many photons there. But again, what are you doing when you're creating smoke? You're just creating little pieces of target. You're just creating the same target. You're just moving pieces of it to different locations. And it still has to be the vectors that still have to combine in phase or out of phase to send you light. So it tells you nothing about the process that you're arguing is how this happens. It's not going to explain why you need two sources to create the photon pattern, the fringe pattern. It's not going to explain that because your two sources are still hitting your speck of dust. You haven't changed the experiment at all. All you've done is move the target closer or further and said, look, same pattern. Well, of course it's the same pattern. It's the same geometry.
Use that. And looking at this, I think it's really hard to understand why you get the crazy double slit pattern.
So the crazy double slit pattern that you totally ignored, okay, you didn't pay any attention to its actual, the way it actually looks, what actually is revealed. You just said it's just noisy mush and ran away from the true pattern.
It seems like obviously you should just get a dot with a line through it.
Why? Why would anyone think that? Again, Newton did the experiment, okay? It's a known fact. It's one of the simplest, like, you know, okay, everybody should know this already. You create fringes. Light is scattered. This isn't a complex idea. Light's diffracted by the atmosphere. I mean, this isn't a complex subject, right? We can't use telescopes on Earth very effectively because there's a bunch of light in the atmosphere coming from all kinds of little particles all over the place. Why? The light came in straight. How come it's coming from all kinds of locations? The sun's there. Why is the light from the sun coming from over there? Well, that's because it actually took that path.
So I've done my PhD in quantum stuff.
So I did my PhD in quantum stuff. This is, you know, that's really scientific, that statement, isn't it? Quantum stuff. Oh, man. All right. So she's making an amateur mistake to think the smoke is going to reveal anything. That's just moving the target to a new location. So she's a PhD. She's a doctor of physics. And I have to explain to her that moving the target that the photon is going to hit or be created on, the creation point of the photon, moving the creation point doesn't change the pattern. I have to explain that.
And I thought I understood the theory of this experiment really well. And so my plan was just...
So she admits she didn't understand it well at all because she just kind of vaguely had some notion that, oh, it's a corpuscle and then it turns into a magical wave and then blah, 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 blah. So obviously, you know, these are conflicting statements. One minute she says, oh yeah, I was kind of mushy about what I thought anything was. And now she's saying, oh, I thought I really understood it. I can play the end of the video where she's basically going to say, I didn't really understand, I didn't blah, 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 blah. And now she's saying, I thought I did. Come on.
Just to explain it to you in a cute little video about how to do this.
Yeah, exactly. So you're already admitting that that's what your frickin' objective is to do cute little science videos. That science should be cute. That, you know, you think that's productive. You know, and you're gonna insult Isaac Newton. Why? Because he wasn't cute enough. He didn't put enough cute little animations in his book. He didn't draw like little people doing little fun stuff and bit 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 bit. Shit.
Experiment at home. Instead, I got sucked into an odyssey for the last few months where I did.
So it's months to do cardboard laser pointer experiments. I mean, crappy, unscientific, imprecise, you know, non-clinical garbage.
All kinds of variations.
I mean, amateur garbage funded by Google.
On the experiment, and I ended up like questioning pretty much everything I thought I knew about light.
Okay, she didn't question any of it. Okay, she just reinforced the propaganda. So that's it. There's nothing. She didn't change anything. She just went, instead of being 98% a wave theorist, she became 100% a wave theorist. I mean, I don't even understand. You know, she's making an argument that somehow somebody uses a particle theory in a textbook to explain the double slit experiment, when that doesn't happen anywhere on Earth. There's no such thing. Particle theory comes from different experiments. It comes from the experiments where you're creating the electrical effects. Okay, it doesn't come, there's no particle explanation for the double slit experiment. They don't even show you a particle explanation. Newton provided no explanation. It's just a fact.
It turns out this experiment is just way more interesting than I thought. There's always been this debate in physics about...
So she's saying it's way more interesting based on the fact that she can't understand basic physics. I mean, really, understanding that you can't use smoke to show you the path of the wave part of the photon. You're not going to see the wave part because, frankly, those photons, two of the sources in the double slit experiment don't make a visible photon. Doesn't matter where you put the target, it doesn't make a visible photon. You won't see a fringe pattern. You need four sources. That's the whole point.
Whether light is made out of a stream of particles or light is some sort of...
So again, stream of particles, and at least she's showing a stream of particles with a frequency here, which is sort of interesting because yes, what would be the photon in this example? The photon would be what? A collection of these particles. You have to have more than one thing hit a surface for it to be called a frequency. So you know that whatever these corpuscles are, they have to hit with some sort of regularity. There can't just be one of them. One of them wouldn't tell you what the wavelength is. If one wave hits the shore, you can't say, oh, the waves are coming every 0.5 seconds. No, they're not. So obviously it has to be made of more than one wave.
Of excitation like a wave. The double slit experiment was meant to definitively prove that light is a...
Okay, it wasn't meant to do any of this stuff, okay? It was just suggested by a pretty good scientist, okay? But he was a wave guy, completely. He was a sound engineer, a doctor, a medical doctor, who was quite obsessed with sound experiments. And so he obviously gravitated towards a wave theory of light. And he did a crude experiment, really crude. It really didn't reveal the double slit at all. These are all experiments Newton had already done. Newton had already done the two-surface experiment, the aperture experiment, and he'd already done the single impediment. So he'd done the two-surface experiments. He just never did the four-surface experiment.
Wave. Except later experiments seem to show that light has particle-like properties as well.
Okay, so other experiments about completely different things, the photoelectric effect, as Feynman would put it, for photomultipliers, the thing don't work that way. Okay, waves don't work. You can't explain how a photodetector works with a wave theory. So she's disputing Richard Feynman. Okay, Feynman says you're thinking about it wrong. Okay, now Feynman's wrong because he thinks every single photon is randomized, and her image of the laser beam sort of shows, well, that can't be true because most of the light goes straight through.
Well, I used to hate this whole wave particle thing because light is clearly neither.
Okay, clearly neither doesn't make any sense, okay? It's neither real or fake. I mean, come on. It has to be one or the other, all right? It either is a substantive thing or it's a motion in something, okay? So you have to concede the point.
A great analogy I heard for it is that light is like a platypus. It doesn't make sense to say that it's both a duck and a beaver at the same time.
Yeah, well, nobody would say that. They call it platypus for that reason. They don't call it duckapus or, beaverit. So we can figure it out. We test it, okay, in a scientific way. Not in a superficial way, in a scientific way. And they find out, well, it's not, the bill isn't made out of the same material. And, and having skin between your fingers isn't all that unique.
Because it is its own thing. But actually doing this experiment finally made me see the value in having good analogy.
Okay, so trivially doing the experiment again. So not doing it more clinically than somebody did it in the 50s or the 60s or the 70s. You have much better imagery out there. So that somehow doesn't help her any. But hands-on, doing it with cardboard So does that make sense to you? It doesn't make sense to me.
To help
So, why don't you just do your own nuclear accelerator? Yeah.
you think about light. And in particular, it really sold me on thinking about light in terms of waves. It also made me see how misleading the...
So again, she was already sold and already propagandizing wave theory. So let's just understand this. Whatever this is, whatever the purpose of this video, okay, it didn't clarify anything that was a confusion to anybody else in the universe.
particle analogy can be if you're not super careful about it.
All right, and you're not super careful. You're not even a little bit careful. You made, obvious mistakes, frankly. I mean, mechanically obvious mistakes in your interpretation of what you were looking at. So when you shove smoke in front of a beam of laser light, you're not seeing the photons that get to the target. You're seeing photons that you're creating on a new target. You put a target in front of the photons. You're just changing the place where the photon is made.
I think many of us imagine photons, which are what physicists now call particles of light.
So again, it's, the word photon is kind of a mistake, okay, frankly. Because it's not a ton, all right? It's not like an electron or a proton. It's not a thing, a single thing. A photon is an event, and you can see that by understanding the electrical theory. We see photons because they cause electricity in our brain. That's how we see them. Our retina turns the energy into an electrical signal. Well, that's how the photomultiplier works. That's how all of it works. It's all based on creating an electrical signal.
In a similar way,
I mean, the photon multiplier doesn't really multiply the photon. It multiplies an electron. It takes the momentum from the photon and converts it into an electron's motion, and then it amplifies the electron.
to how Newton thought of light particles. The double slit experiment shows why Newton's particle view is definitely wrong.
Okay, so she's making an emphatic statement. It's definitely wrong. It's not definitely wrong. This experiment didn't prove it before. It still doesn't prove it. It doesn't undo the photoelectric effect. It doesn't undo the other reasons why you have to concede that they're single corpuscles of light, that they come in a quanta of light. The whole idea of quantum mechanics is based on the idea that it's a quantum, not a wavum. Okay, so until you're willing to start using words like wavicle, you're not going to be able to get to the discreteness of the energy. It's in little tiny singular packets. Wave packet is baby talk, so draw me a wave packet.
Newton imagined light in the same way we now think of water.
So let's understand, Newton didn't make any assertions about anything other than what happens. All right, and all he said is there's every indication of the straight line movement, and that it does the same thing as like gravity, the inverse square law. Lots of things are the same for light, and it makes sense. It's a usable analogy.
Inside, it's just made of a stream of light particles in the same way that water is made out of water particles. I'm going to call these particles that Newton thought light was made out of localized particles, because at every point in time, they're just in one spot in space. They're not.
Yes. So there's no quantum bullshit here that it doesn't know where it is. Yes, it's made out of real stuff moving in the real 3 dimensions. So yes, Newton did believe there was absolute space, that everything existed in these 3 dimensions, and all it could do was move with momentum. And everything that happened was just an exchange of one thing's momentum for another thing's momentum. One thing was moving and would make other things move if it came into contact with them. That's what Newton believed, and you haven't debunked any of it. You haven't made any of it impossible to be true. You haven't demonstrated it not to be true. You've just said it with really bad evidence.
In multiple places or very spread out or anything like that. If you turn
Yes, it clearly behaves like rays of light. The ray theory works for rainbows. It works for so many different things. Even your own double slit mathematics is obsessed with vectors. You're measuring the length of a line to a point source. You're drawing triangles with straight lines. I mean, it's in your own math, the straight lines.
turn down the laser enough, Newton would have expected that light comes out in these individual particles. Instead, people like Thomas Young imagine light coming out as some sort of wave.
Some sort, yes, so there we have it. Some sort. She can't even tell us what sort of wave it would be. That it's some sort of ether in there's a surface on the ether, and it goes into the surface, and somehow the gravity of the surface pushes the wave back down like a water wave. That somehow it's oscillating, even though there's no... What the hell's oscillating? What the hell is causing the resonator to be confined to a space? What's the vessel for the resonator? How does the wave know it's supposed to go this high and then go back down again, then go back up again, then go back down? How does it know how to do any of that stuff? You have no explanation whatsoever about any of these mechanics for this transverse wave. Nothing. They will give you nothing. They'll just draw a silly little picture of a wavy line, and tell you a DNA molecule and say, there, it's a DNA molecule.
In this case, no matter how much you turn down the laser, the light would still be a wave, it would just be less and less wavy.
That's right, it would have less and less impact, where the quanta have the same impact no matter how few photons get to a location. Each photon represents the same amount of energy, so it doesn't matter whether you put your little target it doesn't matter what I put a little piece of smoke right here and bounce the wave to a location, or I wait till I hit the photon way over here and bounce it to a location. Those photons will have exactly the same energy. So the starlight that hits our telescopes has exactly the same energy that it had when it left. Well, actually, its frequency is declined, based on hitting a bunch of hydrogen atoms on its way. But anyway, the point is that the actual speed and momentum of the pieces that make up the photon are exactly the same. Discrete bits of indestructible stuff. You can change where they go, you can't change that they exist.
The light travels forward not in lines, but as peaks of a wave progressing forward.
In the case of just...
Right, and the bottom blue image here doesn't work. Feynman says it doesn't work. That thing doesn't work that way. Those are Feynman's words. So why don't you put Feynman's picture here? Because you're disputing Feynman, Richard Feynman.
Turning on a flashlight, both Newton's picture and Thomas Young's wave picture make exactly the same predictions.
They don't, so that's the whole point. Thomas Young's two-wave image will not create the double slit pattern with openings that are bigger than a wavelength, or bigger than a couple of wavelengths. So any opening bigger than a couple of wavelengths, Thomas Young's image doesn't get the right answer. The two-wave theory cannot and will not work. Because the waves aren't in the center of the openings, first off. They don't even do the math that way. The center of the openings aren't where the wave centers are. The wave centers are on the surfaces, and you have 4 of them in the double slit experiment. So again, just keep ignoring the facts.
But Newton's view just feels bright. Like you have these particles just traveling in...
Alright, so this is more, it seems like... Yeah. No, that's not what physics is supposed to be. Physics is figuring out where we are being tricked, where the illusions exist, and explaining the illusions, explaining the misimpressions. Okay, even a water wave, just looking at it, you're saying, well, the water's moving towards me. Well, that's an illusion. The water doesn't move towards me. Okay, the stuff sitting on the surface doesn't move towards me. The waves don't push very effectively at all. and because the water's really just moving up into gravity. It's just storing the energy it can't use. It can't move the water fast enough, so it has to do something with the momentum because the water is an uncompressible fluid and it will not waste the energy, so it has to shove the energy into the atmosphere. And then eventually the atmosphere shoves it back down into the water. That's what's really happening. That explanation can be accomplished. I mean, you could talk about tides and how, on the surface, you just say something trivial like, well, the moon causes them. Yeah, but it's kind of complicated because the moon is actually putting a gravitational effect that's stronger at the equator than it is at the North Pole, and so it's pulling the water sideways at the poles. It's not pulling it down, it's pulling it sideways.
Straight lines, which is so much simpler than this strange abstract wave thing, which is why it's so
again, it's not simpler in terms of it doesn't provide any explanatory explanation unless you go a little deeper and you understand that atoms aren't balls and photons aren't balls, and the photons aren't just bouncing off of atoms, they're not just bouncing off of a surface, that it's more complicated than that there's actually electrons on the outside of atoms, and that the photons are actually traveling through the electron field, and it's the electrons that are scattering the photons, because that's what electrons do to photons.
tempting to think of light this way. In fact, I've seen pictures just like this one to illustrate.
Okay, show me. Okay, I think that's a lie, frankly. Okay, I think it's a lie that any textbook uses this example and defends it as an explanation for the double slit. They might show it to say how it doesn't work, but they never use it to say how, look, this is how the double slit works. It's particles. They never do that. There's no textbook that does that. So what she's just premised, this premise is not accurate. It's not the truth.
Photons exiting a light source in many reputable textbooks.
Okay, no, you haven't. You haven't seen that. You haven't seen it as a explanation where the textbook was actually saying, look how good a particle theory explains the double slit. Here's an example. No examples ever in a textbook, so that's just not accurate.
And I get why. That's kind of how I imagine photons too.
So again, just this is absolute nonsense. All right? She has no imagination. There's no model in any textbook that shows particles creating the double slit pattern. No model. No defense of the particle explanation in any textbook. That doesn't happen. That's not the truth. You're just telling a fricking lie.
So how did Thomas Young go about disproving it?
So, and again, he didn't disprove anything. His own drawing doesn't get the right answers. His own drawing doesn't accurately predict. How can he possibly prove something with an inaccurate prediction?
He needed to find an experiment that could only be explained with waves and not with Newton's particles.
So, and again, Newton's particles. No, corpuscles of light. That's Newton, okay? Newton didn't say particle, he said corpuscle. Feynman said clump. Okay, so yeah, it's a little more complicated than what you want to force the argument to be. So yes, you would like to pigeonhole anybody who says this or that as this or that, right? You want to call them a bigot or do this or do that. So you want to call everybody who believes that it is made out of quantized clumps of momentum, that they must be in this category. And that gives me the right to say that every one of you is really searching for the God wave, the God wavicle, that your only ambition is to regenerate your ether, your godly ether.
Well, one unique thing that waves do is that they bend and spread out.
So whatever that means. Okay. And it's not unique. There's really, I mean, stuff hitting a brick wall bends and spreads out. I mean, everything bends and spreads out essentially, unless you do the Newton's cradle thing, unless you have equal mass against equal mass. But every time I have uneven masses interacting, I get bending and spreading out.
You may have seen this before, but for me at least, it was kind of surprising.
Let me show you with this high-tech ripple tank I made.
So this isn't high, right? So she's insulting her own thing by saying it's not high tech. It's the exact opposite of high tech. So it's really amateur and low tech. So again, keep doing it to deceive. Don't do it to get to the truth. Don't do the experiment well enough to actually create valid evidence. Just keep doing it this cheater's way. Just like Veritasium when he did his single photon experiment, and it didn't work when he allowed the machine to take 2 hours. And he had to keep making the time shorter and shorter and shorter to get it to work. Isn't that ironic? So to do a time exposure, he somehow had to have less and less time to actually get it to work. So clearly it wasn't about the truth. It was about just forcing a result.
Yeah. You can see that when I bob this plastic in the water, it makes fairly straight waves. But what...
I mean, she says fairly straight. They're wobbling all over the place, but whatever. I mean, okay, sure.
What do you expect will happen when
I mean, really, they're not very straight.
I put this obstruction in the way?
So it's a gigantic obstruction, right? So, and it's an obstruction that has a wall on the other side of the opening. So again, yes, this will force a certain result. If she did it with a smaller obstruction, you might not see as much bending of the waves because the waves wouldn't have tension on both sides and they wouldn't be round.
Way. I would have guessed that the bit of the wave that makes it pass just goes...
So again, this is the fake part, right? She has this little blip, blip, blip. This is the wave center is somehow out here in the middle of nowhere when their math dictates the surface. So if I did this, if we just put this image and just flip it over to the other side and create a double slit, I mean a single slit experiment, where are the waves? The waves aren't where she just put this point source. The point source is exactly on the surface. That's the math that gets the right answer. That's where you have to draw your vectors from. The surfaces. That's where you draw your lines to see which line is a wavelength more distance. You draw your lines from the surface. Not halfway out, not 3/4, not in space somewhere. On the surface. The center of that little O should be right on the surface, because that's where the point source is.
Straight ahead, and that's what the majority of the wave does do.
So what is this image? I mean, it's this whole fake idea that she's just counting the wave that's going straight and she's not counting all the rest of the stuff going in all these other directions. That's all supposed to be energy of the photon, so you have a whole bunch of magical energy you're creating. You put one little thing in, one little straight bar goes in, you create a gigantically huge, monstrous thing that never gets any weaker. Doesn't make any sense. The photon doesn't get any weaker, yet you spread it over all of this space. Come on.
But the rest of it bends and spreads out. You can see that in action here. But why does it
You can't see anything. So yeah, so all these, you know, the slow motion camera people, all this other stuff, and this is what we get as an experiment. So clearly there's a mechanics to what water's doing, right? The water has friction with the surface. That is, the water actually slows down on the surfaces. That's why it creates a round wave. There's no other reason. The surface is entirely the reason. It's slowing down. The water molecules are stuck to each other. So yes, you slow down the ones on the side, it's going to bend. All the others have to yield because they have to wait for the other water, okay, to catch up, to get back up to speed.
happen?
Obviously, photons aren't doing that. Photons aren't encountering friction with surfaces. There's no theory for your round photon wave.
I don't really know. I would love to understand it better and make a video about it, but until then, you can see that this is something waves actually do.
Yeah, they do them when you contrive an experiment to show an effect, and it's not very effective in showing anything except, again, something that's mathematically not accurate. So just do the single slit with your wave, and then point out how there's one wave coming out of the single slit. So why don't you show that experiment? Oh, because that would illustrate that this wave analogy doesn't work. Because water doesn't do that. Water doesn't create a fringe pattern with a single opening. Because it doesn't create two waves.
Spread out when they meet an obstacle.
That definitely feels a lot different from how I'd expect particles to behave. So why don't we do a similar...
Yeah, so just cheat. You know, did you use a sandblaster or some kind of mechanism that's made out of particles and see how many particles actually do come out sideways?
experiment with light and see what happens. Will light bend and spread out, or will it go straight? I'm going to use a piece of paper as the obstruction device.
So it's just so bad, right? I mean, this is handheld piece of paper. This is her improvement. This is what she's doing to get to the truth. So, I mean, it's just, again, I could go on Google and you can see laboratory experiments doing the same thing, and they're going to do it with a lot more quality than this. How is this advancing the subject any?
Find out. And there you go.
It's an absolutely horrible pattern. Yes, it's disgusting. It's terrible. It's a terrible image. Your videographer sucks. I mean, there's not much to say here, but she's going to say something right here that is so critical. Again, this is a critical part of the argumentation, and again, there's going to be an obvious, I mean, trivially obvious, stupid mistake. I mean, it's just stupid. She should know better. I mean, she's going to insult Newton. Newton wrote a whole book on optics, okay? And she's not going to pay any attention. Knowledge he had in the 1600s, and she's going to mock him, and she's more ignorant than he is. He knew better in the 1600s. Before the camera was even invented, he knew the mistake you're making.
The laser light does actually spread out. Case closed. Light is a wave, right? Well,
no, that's a case closed. Pathetic.
Well, maybe we should give Newton a chance to rebut this.
All right, so again, she keeps using Newton, a dead guy, okay, and patronizingly and obnoxiously insulting his physics and the integrity of his science. I mean, it's just tacky. There's nothing to say about this. This is a tacky approach. You're in competition with Newton. Well, Newton's dead. I mean, you think that's a fair fight? I'm offering you $2,000 to fight a living person, somebody who will defend Newton as being quite logical and quite reasonable. And he didn't make any stupid, trivial mistakes like you're making.
I guess he could try and explain this with particles, perhaps.
So again, her drawing of particles, all of a sudden they're scattering way out here for no reason. Right? It's going by the surface, and I don't know what that black thing is. What the fuck is that? Why don't you just have the surface and the particles are going next to the surface? Then you can explain how, well, atoms are made of protons and electrons. They're made of a nucleon and electrons surrounding it, very, very far away from that nucleon. So there's a whole bunch of empty space in atoms, and the empty space is basically filled with electrons. And what happens when a photon hits an electron? Oh, the photon scatters. The photon goes in different directions than what it came in. She's just doing a little frowny face for Newton. Oh yeah, I was dumb, I was stupid, I got the wrong answer. No, he didn't do any of that. He did really disciplined and careful science, and he didn't sit there and do this trivial mock somebody else in his damn book thing.
The particles are colliding into the paper and then ricocheting, and that's why they spread out like this.
So again, who says this? This isn't Newton. Newton didn't say this happened. So whose theory is this? The one you made up, the straw man you created. The straw man, look, I collected a bunch of smiley face photons on the surface. Whose theory is that? Who? Where is that? Where is that even published somewhere? Where is this straw man published? Whose argument is it? Is it Einstein's? No. Is it Newton's? No. Is it Feynman's? No. Will you tell us whose it is?
Okay, fine. Maybe you can explain that. But there is another wave phenomenon that particles definitely can't mimic, and that's cancer.
So again, she's definitely, you can't possibly explain these phenomena. You can't possibly do it. Newton couldn't possibly do it. No scientist ever will possibly do it, because you think you can't see how arrogant, pompous, and stupid you are to do this. Especially when in the end of the video you're going to say how you have to be careful and all that kind of crap.
Canceling out.
One way to think of the last experiment is that it's like we took the hair experiment and then just blocked one path.
We found that at least...
So this is the famous bullshit that somehow there's a place, that Feynman says this too, okay, there's a place that has light hitting it. It's hitting the location, okay? There's a location, light is hitting it. And now I undo the other slit and the light goes away. This experiment has never been done. Veritasium couldn't make it happen, okay, in his single photon experiment. And it never happens. There's no evidence this ever happens. There's no visual evidence anywhere in the scientific records of this actually happening in some sort of clinical, dissectable way. Now, there's people making claims, just like she's going to make a claim. But those claims always come with a catch. And the catch is so obvious here. Again, this is a trivially stupid mistake. Newton knew better. Newton knew you can't do what she's going to do.
Some of the light ends up in all of these places, including in this spot.
All right, so she's just pointing to some spot. You can't see what's at the spot. You can't even see that there's light at that spot. You see absolutely nothing. But look at how dark the background is, right? The aperture on the camera, this is obviously only half as much light. The aperture in the camera has shrunk down to increase the exposure because there isn't enough light.
If we had blocked the right path instead, we'd have gotten a very similar result.
So, can you see how much lighter the background is? Now let's go to the one that matters.
And again, notice that at least some of the light falls on this spot. Now let's open both paths simultaneously.
So look how crudely done this experiment was. So you saw how dark it was the first time. Look how light it is now, right? So obviously it's just an aperture, okay? It's twice as much light. The camera has closed down, obviously to increase the contrast so you could see this spot. This spot has, and again, look at the way she's done this experiment. I mean, you obviously have the little bands that you can't even see them now. They were the only thing creating the bars before, was the little ones, right? Because you didn't have the two slits. So, I mean, now they've obviously gotten much smaller. Why? Because now you have the outside, the second slit surface. You have the two surfaces that are further apart. So now the bands have become so small you can't even see them.
Appears from this spot. There is no way for Newton to explain.
All right, so of course you can explain it by just saying exposure. All right, if you have the same exposure, you won't be able to defend that experiment. So if you lock the exposure on the camera, you'll see that, well, your first image was so bad anyway. Let's just go back to the first image because it was so bad. I mean, where she puts the arrow. What is she pointing the arrow at?
And again, notice that at least some of
there are bars here. You just can't barely see them. It's so blurry.
the light falls on this spot.
Right. So she's saying this spot is light. I don't know. Is it? And look, the arrow. Look how far the arrow is from the spot. So here's the center, and here's her arrow. And then look what she's going to do in the other image. I mean, there's no way this is in any way has any scientific credibility.
There is no way for Newton.
So you can see that, the arrow is much further away. The spot's in a different location. The whole thing's a piece of crap.
And the light just disappears.
Yeah, not even close. But anyway, all right, so garbage, rubbish, okay. There's no clinical evidence of this phenomenon. And the fact is if you keep the exposure the same, what you'll see is that at the same exposure the camera's at now, you won't see the fringe pattern when you have one side blocked. You won't even see it. It'll be so faint and so almost not there. And that's what you'll see. And if you actually do detail these slit experiments, you always see that there is a little bit of light in the dark spots. They're not completely dark. They never are. Because, yeah, there's all kinds of light being diffracted, and there's some light hitting all those locations. But anyway. Alright, so we'll call that video 1. So just 2 fake things. Fake, not recognizing you have to have the same exposure on the camera, and you certainly have to take a better image than this if you're going to claim a proof. Alright, this is garbage as experimental evidence. This is so poorly, I mean, it's beneath amateur. There's amateurs who've taken better pictures of double slit experiments. It's terrible. I mean, this is Google Finance Science. Oh, it's garbage. And then she can't figure out that, putting little mirrors, popping a little mirror in space, little dust blobs, doesn't change the fact that it's still 2 sources that are creating the photon on the surface. So no matter where I put the surface, doesn't change the double slit experiment. It doesn't change the single slit experiment. I'll see exactly the same fringe pattern whether I put the target a foot away or 10 feet away or 100 feet away. I'll see the same pattern. Yes, it'll be a different size, but it'll be exactly the same pattern. And it's being created by the same phenomenon, which is photons you can't see are hitting the surface. And they're combining into a photon. That's your own theory. Your own wave theory requires that to happen. The constructive interference has to actually happen at the surface. The 2 sources have to hit the surface to create the photon. Oh, man. All right. So we will do the second half of this and blah, 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 blah. And then I'll have to do an update video too because, yeah, I had a couple of good videos on the website, so I will point to those also in a video. But this is terrible. I want to say a bunch of politically incorrect things, but I won't now. Maybe I'll put a video on the website because this is really bad science, and it's so obnoxious. The presentation is just obnoxiously arrogant, pompous, dogmatic, and it's really crappy science. And such. So anyway, this has been draftphysics.com, debatephysics.com also, but the cowards will not debate. I have offered her channel $2,000 in the past. No, not even a message back. They're all just cowards. They can't deal with the facts. All they are presenters of dogmatic fables. They're just religious kooks.